Just a quick introduction. This is Saravana. So I'm from Soliton Technologies, basically located in India. So I will be sharing few thought process and few things that we are doing to make the LabVIEW build software as a scalable one that can coexist with the other programming technologies and languages, right? So that's what we are going to discuss today. So just jumping into a little bit of prerequisite we can consider. Um, so let's say why a software should be scalable, right? So say if we talk about an organization which builds like test and measurement software, and there are multiple teams working to build those tests or measurements, right? So if there are no standard software tools, then it leads to a lot of scattered, disconnected tools and software, right? And there will not be reusability between the groups, right? So each team will go ahead and end up in developing everything from scratch, from new, and between the teams also they cannot reuse, or within the teams also they don't know like what others has done, and the overall reusability and the maintainability goes down, right? And after a few years, if the corresponding person who develops that particular tool leaves the company, then again like then that will be scrapped off and it will be created newly, right? So whereas when we build a standard software, that will help us to reduce this software framework development time. So framework is built in the beginning, and now all the modules like test modules or machine modules are built as a plugins. So it reduces the total framework building time. It's a one-time development effort, right? And all the teams can reuse it, and they can only it is okay for them to build only the sub modules or measurements, right? And also they can also reuse the sub modules built by the different teams. Say for example, I make an module to make a measurement A. The same measurement A, if some other team or some other person wants to use it, he can directly get it from me, or I can also host it in somewhere in my server or some place where people can get it, and they can use it readily, right? So that it promotes reuse of submodules, utilities, and tools. And again, since the framework is standard, it's easy to kind of deploy and reproduce the test setups easily across different benches. So that's one of the greatest advantage it gives. And finally, since it allows to reuse, it gives greater collaboration between teams. Multiple teams can collaborate together in making the framework better and in building a lot of modules, right? So thus building a standard software provides these many advantages over maintaining scattered and disconnected software tools across the organization, right? So now let's see what is one of the pain point that, or what is one of the important barrier that is not allowing many people to build a scalable or standard software framework. So the one of the important barrier is the programming technology or the language we are going to use, right? So it may be due to a different reasons. Say due to the entry of new engineers from universities, where they get trained in different programming language, or due to regional effect, or due to some other reasons. Different people use different programming technology for building automation. If you use LabVIEW, if you use C Sharp, if you use Python, if you use Java, right? So at the end of the day, each one prefers to have their piece of software in the language they prefer, and thus it leads to scattered software pieces. So a person who a team or a person who's dominant in LabVIEW creates all the infrastructure in LabVIEW and keep it. A person who is dominant in C Sharp build it in C Sharp and keep it, right? So they cannot reuse both the things together. They cannot or they cannot leverage whatever the other has done, right? So that's the important barrier that is not allowing us to build a standard framework across the organization or across the board, right? So and even some cases we might need to use the software across different operating systems as well, which is not possible, right? So to kind of overcome this issue and build a scalable software framework, so we have some thought process on top of it. So uh, so this is the overall structure that I'm kind of visualizing, right? So there is a software framework. So this framework can be built on any technology stack. It may be on LabVIEW or C# or Python, and it should support the submodules that has been developed in different programming languages, right? So in the sense, the core, the high level skeleton structure alone will reside in one programming language called as framework, but the core business logic, what is the test that we are going to do, or the measurement or the functionality that we are going to do, the developers can do it in the languages that they are comfortable, but this framework should allow them to import their items or use their plugins or modules that they have created, and along with the overall framework, right? So that's the idea that we are thinking that can overcome this. And how to do it, we can use this concept of microservices, right? So microservices is nothing but a bigger application is kind of like broken down into multiple small individual units that run separately, and there is an gateway that can coordinate between these services, and the top level software can get the work done by these services correspondingly, right? So if you look at the bigger software tool has some services gateway which allows them to discover what are the different services running, and we can talk between these services and get the job done, and software tool can do the other stuff, right? So this all the communication is done by remote procedure called RPC communications, right? So for example, I need to do a measurement A and I need to do a test B. Measurement A can be a service 1 and test B can be a service 2. And the software tool, let's imagine like an tool where the user configures to do measurement A and test B, right? And it knows what service to call in the backend using the services manager, and it passes the inputs what user gives to the service, make the service to do the measurement and get back the result and populate it to the user. So that's the kind of visualization, or that's the kind of architecture we can do with this microservices, which will help us to leverage these concepts to build the scalable framework that what we are looking for. So one of the important RPC communications that will help us to do is this gRPC. So recently, in the last couple of years, NI is actively working to build this gRPC libraries for LabVIEW. So basically, gRPC has this server and client architecture similar to TCP. So the client can request something from server and send some data, which is called as proto request, and server can do the functionality and it can respond back to the client giving the data, which it's called as proto response, right? And any number of clients can be getting connected to the server. So it's more like a server client communication. So this is more like a cross platform. The server can reside in any programming language, client can reside in any programming language. It need not to be like a same programming language. So gRPC takes care of transferring the information between both the server and client. So let me quickly touch upon what are the different things gRPC has, right? So the important elements of gRPC are, first is the proto message, right? So the first step is defining what type of messages has to be sent between the server and client, right? So which we call it as proto message. So for example, if you like take this example, here we have defined this message called person. Uh, it has three data associated with it: name, ID, and whether he has a credit card or not, right? So these are the three data, and the data type is also defined, right? So this is a message. So say for example, a client wants to send the person information to server and see if he has if he needs to do something based on credit card, this client can send this information to the server. And likewise, for our application, we can define a number of messages like this, like what data we have to pass between the server and client, and that has to be defined, and it will be written to a specific file which is called as a proto file, right? And this proto file acts as a base, and LabVIEW, I think NI has given some utilities to kind of like generate the gRPC LabVIEW server and client modules using this profile, which we will see next, right? So these are the key elements that is needed for gRPC. So just quickly touching upon the profile, as I mentioned earlier, the profile contains most of the proto messages that we wanted to send. For example, here we can see different messages getting created, right? It's a collection of the data that we want to send it through the gRPC communication, right? And moving on. So how to build a gRPC server? So first step is, as I mentioned, we have to define the proto messages that we want to share between the client and server. Then move it to the profile and creating the right profile with the format. There are set rules and definitions for profile format. So creating that. Once that is done, NI has this gRPC template creation utility, which can be accessed in the below link, right? Tool gRPC open gRPC server client code generation VA, right? And once this is launched, we need to give the file path, the profile path where the target library should be generated, name of it. And if we choose to create a gRPC server, this utility creates a gRPC server. If you choose to create a gRPC client, this utility creates a gRPC client, and that's simple. And it comes with a list of APIs, which you can directly use it in your software, or you can put the core logic of your software into these APIs, which you can feel free to do the either way or that you want, right? So basically, this will help us to like build gRPC server and client in LabVIEW. Similarly, there are different ways to create the clients and servers in different programming languages as well, right? So now we have the server and client architecture. So the software framework can use gRPCs to communicate between submodules, and the submodule can be different clients or it can be different servers. And the main software framework can talk to all these different applications that is built in different programming languages. So that's the key advantage this gRPC is offering us, right? So what are the values that it provides? So first, it helps us to build the scalable software, right? That can leverage multiple programming language. No more the programming language is a barrier to build a scalable software or standard software within the organization, right? Or no more the reusability should stay within one programming language, right? So developers can choose their programming language of their choice, and the central framework can support all these programming languages, right? And instead of monolithic application, it's a microservice based architecture, which allows to leverage the advantages of microservices, right? And the third item is it leverages the positives of other programming language. Say, for example, I want to do an image processing, or I want to do some small data science kind of analysis and get the results. It's far easy to do it in Python compared to C# or in other programming language. So that particular piece can be in Python, and I can maybe my software is in LabVIEW. I can pass this the metadata to this Python and then do that processing and get back the results, right? So this helps to like leverage the plus points of each programming languages and helping us to be in a centralized framework, right? And again, it has an ability to generate APIs for multiple programming languages, so it can be used as a native library, right? So these are the key values this gRPC based architecture will offer to the user. So just a quick info: the gRPC support is still improved by NI, and this is the link where the gRPC can be downloaded under open source MIT license. So both server and client is supported by NI, and there are certain NI devices that can be remotely accessed using gRPC servers now, and this link contains that as well, right? And these are certain reference links from where this presentation is collected, and that's I think I'm right on time, and I think that's pretty much I wanted to cover.